Okay, guys, in this video, we are going to connect the rectangular coordinates and polar coordinates, okay? So what is the connection? All right, so let's discuss it. So first of all, let's see what happens with rectangular coordinates. With rectangular coordinates, x is just the horizontal distance, right, to get to this point. So imagine this is point P, we're trying to get there. So first we're gonna go along the x-axis, right? And this distance from here to here, that's gonna be x, right? And then we're gonna go y would be this part, right? So that's gonna be y. And then what is r? R is the distance from the point to the origin. So that's your r. Now it's pretty clear from the Pythagorean theorem is that x squared plus y squared is going to be r squared. So that's a connection that you need to know because this happens a lot. When you're trying to switch from rectangular to polar coordinates, you're going to see this x squared plus y squared, and you should immediately say, oh, that's just r squared. Okay, the connection with the x and y and angle theta also is going to be something that you will need to know. So from the definition of cosine of an angle, right, because that's just the adjacent side divided by the hypotenuse from here, right? So we have adjacent side is x and hypotenuse is r. From here, if you multiply both sides by r, you will get the connection x equals r cosine theta. Okay, so we already know that x is r cosine theta, so we need to know that. And then also from the definition of the sine of an angle, it's going to be in a right triangle. It's going to be opposite side over hypotenuse. So this is going to be y over r. And from here, y would be r sine theta. Okay, there you go. All right, now there is also another formula possibly for theta, but that one's more difficult. If it's just in the first quadrant, then this would be inverse tangent of y over x, but I don't think we're gonna use it that much, and it's not quite that easy if it's not the first quadrant. I don't want to get in the weeds. So let's just say this is going to be enough for us, these three formulas to convert. So if we want to convert rectangular coordinates here, so 2 plus 5x squared plus 5y squared. Well, all we're going to do is just factor out the 5, and we're going to see x squared plus y squared. And the moment you see that, then you immediately substitute r squared, right? Because we know that x squared plus y squared equals r squared. So that would be 2 plus 5 r squared. Okay, how about this next one? So the next one is going to be 5 minus 8x squared minus 8y squared. And again, we want to switch from x and y to r and theta. So here is going to be a little bit more complicated, but not too bad, right? Because what will happen is you can factor out the negative 8, and then you will get x squared and then y squared. What's important to understand is what sign will be over here in between. So if you put a minus, that's actually going to be incorrect, because if you start distributing, you're going to get negative 8 squared plus 8y squared, right? So that's not right. So actually this should be a plus, okay? And then again, oh, you should recognize that x squared plus y squared, oh, I know what that is. That's just r squared. So this is going to be important because when you start integrating, you're going to have to convert your integrand, or whatever you're integrating, from x and y to r and theta in order to successfully integrate it. Finally, this last example, that's going to be a little more tricky because you do not see the familiar x squared plus y squared. So sometimes what will happen is you won't be able to just see that expression in your integrand, but you only will see x or y without the squares, and you can't really use that x squared plus y squared equal r squared connection. But what you can do instead is, as we talked about, x equals r cosine theta and y equals r sine theta. So we can substitute that. So this is going to be, instead of x, I'm going to put r cosine theta, and then instead of y, I'm going to put r sine theta, and minus 7, obviously that's going to stay the same. So here, cosine theta, and then that's plus 8 r sine theta minus 7.